If you want to be a React developer these days, you also need to know TypeScript. TypeScript has become a de facto standard in React applications. In this video, I'll show you all the TypeScript things that you need to know as a React developer. So right now you can see I have a simple button component and it's using the JSX extension. So if you're ready for this, let's convert this into TSX. I'm going to say this button now needs to start using TypeScript. You can see when I do that, it immediately changes this icon here. I'm going to press enter and now we have enabled TypeScript in this file. So let's start off with the most common things you want to do in TypeScript. Let's say we have some kind of variable. I can just write a variable like I'm always doing in JavaScript. But now if you hover this variable, you can see that there is some type connected to this. And we have not specified this type ourselves. We could do that. We can say this URL is going to be of type string. You use the colon and then the type. We could also say number, and then you're going to get red squiggly line because now we're trying to assign a string to a variable that we just annotated as a number. So it should be a string, but you don't have to do this because TypeScript is smart enough to infer from what you're assigning to that variable what the type is going to be. It sees that you're trying to assign a string to this variable, so it will automatically infer this variable to be of type string. So we don't need to specify that. Now what's the benefit of having that type? Well, now later if I try to assign some other value to it that's a different type, I'm going to get a warning, a red squiggly line from TypeScript. I'm trying to assign a number now to a variable that's supposed to be of type string. So TypeScript is helping us out here. It's telling us this is probably not what you want to do. Besides variables, we also often want to type functions. So let's say we have some function here, convert currency, and it will take two arguments, let's say an amount, and then also the currency that we want to convert that amount into. And then here in the function body, we would have the actual implementation. Now in the function body, typically we don't want to type anything, but we do want to type the function parameters. If you don't type them, actually we're going to get red squiggly lines here. We're going to get a warning from TypeScript because it can't infer anything here and we haven't specified it ourselves. So by default, it's going to be of type any, which is not what we want. Any means anything goes. We can do whatever we want with it. It basically defeats the purpose of using TypeScript in the first place if you're using any. We do want to type this as specifically as we can. So the amount is going to be of type number, let's say, and the currency can be a string, USD, EUR for euro. So then I can call that function convert currency with, for example, the number 100 and then a string. If I now make a mistake here, if I now type in a string as the first argument, you can see TypeScript warns us, hey, you're trying to pass a string here, but it's expecting a number type, right? So TypeScript is helping us out here. It prevents us from making this mistake. Also, if I try to pass in another number here as the second argument, TypeScript is telling us, nope, that's not what you want to do. You want to pass a string here. And then we can also specify the return type. This is usually not necessary, but sometimes you want to do that. So if you want to specify what this function should return, maybe it should return a string, let's say, then if you call that function, you're going to get back a string. I get red squiggly lines now because I'm not returning anything here in the function body because it's just an example. All right, so now let's talk about how you can use this in React. So in React, we have components, and these are actually just functions like we just saw, except you write the name with a capital case. And in the world of React, we call these parameters props. So typically you're going to get props here. And just like before, we want to type those parameters. We want to type the props, and we don't really want to type the return values. So with React components, typically the only thing you want to type are the props. Now in the past, people often did the following to type components. So if you had some component function and then to type it, people would use colon React.FC. And then in here, you could specify the type of the component props. This looks a bit complicated, but this is how it was done mostly in the past. You will still see this sometimes, but there are some issues with this FC and therefore it has gotten out of fashion. And it was also only possible to type this if you wrote your component function like this, so as an arrow function. And you can still do that, of course, nothing wrong with it. Personally, I prefer this traditional function syntax for a component. And let's say that our function is going to receive some props. So I have added the button to our page. Here I'm using the component. And now let's say I want to be able to pass, let's say, the background color. I want to be able to set the background color when I use this component, right? Maybe I want to be able to set it to red. So I should be able to pass in this background color prop. But if I do that now, I get a warning from TypeScript because TypeScript is telling us you're not accepting any props. So now we need to actually accept the props. So we have props, and that's just an object that holds all the props. So if we want to get the background color from there, we can do props.background color, right? And then we can use that background color here in the class name to change the background color, let's say. But let's focus on TypeScript in this video. So now we have props, but we haven't typed this. So to type this, we can use colon, and now it's not going to be string or number because props is an object. To type an object, we can just use curly braces, and then we can say in there there's going to be a property background color, and that one is going to be of type string. So if I do this, this is now properly typed. The props is an object, and in there we just have background color as a string. If I now try to pass a number, let's say number 5, we get an issue from TypeScript. Right? TypeScript is helping us out. You have to pass a string here. Now, typically, you don't write your React components like this. Typically, you destructure this. So here you can destructure it like this. So instead of doing props.background color, you can just write props and then just destructure it from props like that, or just immediately here in the parameter list immediately destructure it here, and that's actually more common. So instead of writing props, you can actually already just immediately write that destructuring in the parameter list like this. So this is a more typical syntax that you're going to see in React components. So the props here, it's still an object, but we are immediately destructuring it here, and therefore we should still describe this as an object. Now let's say we want to pass a font size as well. So what we want to be able to do is say the font size should be some number, let's say. Maybe font size should be 30. And we get red squiggly lines because we are not accepting a prop called font size here. So here now we need to accept a prop called font size, and we are immediately going to destructure that here, but we also need to specify this to TypeScript. We're going to tell TypeScript, hey, we expect a font size, and that's going to be of type number. And the benefit of this is now when I try to pass something like 40 pixels, let's say, which is a pretty common mistake that you could make here, TypeScript is going to tell us, hey, don't do this. You should pass a number here, right? So you can already see TypeScript is helping us out here. It's preventing us from making mistakes. So we have the type string, type number, and the third common type primitive is Boolean. So let's say we also have some Boolean. We want to be able to specify whether this button should be a pill shape or not. So we could say pill shape should be true, let's say. So now we need to accept a pill shape here. So we'll say we're going to destructure that pill shape from the props, and then we're going to specify it here for TypeScript. We're going to say this is going to be a Boolean, true or false. Now you can see the syntax here is quite ugly. It looks like we're sort of repeating ourselves. So we have curly braces here with all these props, and then we sort of have the same here. It looks like the same thing. So it's bloating up our component here quite a bit, especially if you have many props. So instead of writing it inline like this, maybe we should extract this into a separate type. We're going to create a separate type. So in TypeScript we have type, and we can call that, let's say, button props. I like to use the name of the component and then just add props. And we can say, well, this props, what's going to be an object with all this stuff here, all these properties. So we can just paste this here, and now we can use this name. Instead of writing it inline, we can just specify this name here. You can see now it's much cleaner. It works the exact same. So the benefits are TypeScript helps us prevent mistakes, but it goes beyond that. Let's say we don't know the properties that we can pass here. I'm using the button and I want to see the options essentially. So I can press Control space here, and TypeScript is telling us these are the properties that this button can accept. We have background color of type string, we have font size of type number, and we have this pill shape of type Boolean. So I get this very handy IntelliSense as well. When I remove these now, by the way, we see a red squiggly line. So if we look at this, we can see there is some problem here. So we are not passing anything here, and that's a problem because the way that we've done it now is that we have made these mandatory. So if I add 2 of them back, we still get this red squiggly line because we are still missing one, which is pill shape. We don't have pill shape here, but the way that we've done it now is that these are all mandatory. So if we miss one, we're going to get a warning. I can make them optional by having this question mark here. So now if I go back, you can see the red squiggly line is gone because the pill shape now is optional. Another benefit of TypeScript is that let's say I want to use some method here on the background color variable. This is a string. So if I do this to uppercase, this works without problem. But if I try to do the same thing with font size, which is of type number, I get a warning here because to uppercase is a method that doesn't exist on type number. TypeScript helps us out with using these methods as well. If we don't type this, so if I just remove this font size is going to be of type any by default. And sometimes you will also see people make that explicit. So they'll say this font size is going to be of type any. So any means anything goes. So when I do this now, suddenly I don't get red squiggly line here. So now I could be passing a number here and I'm trying to do .to uppercase, but this would cause an error. It could cause our application to crash. It could cause a lot of bugs in our code. And that's the problem with the any type. Any means anything goes. You can do whatever you want, but then why are you using TypeScript in the first place? Right? So we do want to type these things as specifically as we can. So here when I type it as number again, you can see we get a warning, so we can fix it. So let me remove that. We are now typing the parameters of this component. Do we also need to type the return value of this component? So it's returning this button here. This is something called a JSX element, this button here. We don't have to type this ourselves. So if I remove this and just hover button, you can see it's already inferred that we are returning this JSX element. So TypeScript can infer a lot. You just have to follow the red squiggly lines. Let's talk a little bit more about the other types that we have in TypeScript. Instead of accepting any string for the background color, maybe we can be more specific than that. Maybe we only want to allow the string red or the string blue or the string green. So you use this pipe symbol, and this entire thing is called a union type. And it's possible that we want to use that for other properties as well. For example, we may also have a text color prop, and maybe that one needs to accept the same strings. Now we are duplicating ourselves. So what we can do is we can extract this out into its own type. So we can have another type here, and we can simply call that colors. And that's going to be the union type. Now I named this colors, the plural, but typically it's actually better to leave this as the singular name. So the color is going to be either red, blue, or green. And then we can specify color here, right? So you can extract new types like that and just combine them like this. Now if I want to make a change here, maybe add another color or other colors, I only have to change it in one place. Now because I added text color here and I didn't make it optional, so now we're going to get red squiggly lines here because I'm not passing text color. So let's say I make text color the string purple. Now we get rid of the red squiggly lines. All right, so what about arrays? Maybe we want to accept a padding prop. And with padding you have multiple sides, right? So you have top, right, bottom, left. So maybe this can be some kind of array. So what we can do is something like this. So it shouldn't be just a number, it should be an array of numbers. You can just tack on these square brackets, and that means it should be an array of this type. I can do the same thing here, and now it's going to be an array of booleans. I can even do it with my own custom type, right? Now it's going to be an array of these colors. For padding now, I need to pass it in. So how does that look like? Well, for padding, now I need to pass an array here. So it's going to be square brackets, and it should all be numbers, right? So if I try to do something like 5 pixels, 10 pixels, TypeScript is warning me, hey, this shouldn't be in this format, it should be a number, right? Type string is not assignable to type number. So it should be 5, 10, 20, 50. And the problem here is I can add even more. I have not restricted the length. So there is another type, and it's a bit more rare. It's called a tuple. So instead of writing it like this, you actually want to write it in the array. So if you just specify number, number, number like this, you get a so-called tuple, which is basically just a more specific array, right? So tuple is not something that you heard about before as a normal JavaScript developer. But in the world of TypeScript, it basically just means an array, but a little bit more specific than that. So basically you specify how many there should be and in what order, what specific types there should be. So here we just have 4 numbers. So now if I try to add more than 4, I get a warning from TypeScript, so I can fix the problem, right? So I just have to remove these. Now I have 4 elements in the array, and now this works as well. Of course, I should also accept it here in my actual parameter list. Right, so now we add a text color as well as padding. All right, so I'm using Tailwind here, but let's say that we want to use just plain styles. We of course also have the style attribute, and here you can pass an object. So I can have another curly braces here, and here we can set background color to the background color that we pass, color to that text color, font size. You know, we can deal with the padding like this. Actually, Copilot is helping me out here, right? So we can process that array of numbers into an acceptable format here, and we can have many more properties to deal with all sorts of CSS properties that we can add. But that's a lot of work. So instead of doing all of these CSS properties individually, how about we will just have one style object, and then instead of having all of this individually, we're just going to use that style prop here. So we want to be able to accept an object now. So let's remove this. I'm just going to remove all of this. So button props, we now are going to have this style, and this style is going to be an object. So to describe an object, we have curly braces, and then we could have background color, font size, etc. Text color, and I could specify this object like this, and then here when we use that object, let me remove all of this. Now we need to pass one object here for the style prop. So we have JSX syntax, JSX curly braces, and then we have the actual object that we want to pass. That's going to be background color, font size, and let's say text color. And this is how you type an object. And actually the props themselves are also an object. So that's also why we have curly braces here. Now, of course, we can have hundreds of these properties, and it would be very cumbersome to specify all of them individually like this. So we also get some help from React. So we also have some types that we get with React here out of the box. Instead of specifying our own object, we can just use one of the types that we get from React. React here. So we can say React.CSSProperties, right? So now we're not specifying our own object. React is now specifying that object for us, right? So just like we had our own type for color, right? So we had our own color type. We also get some types here when you work with React, just to help us out. So now we can pass any CSS property that we want. And text color is actually not a CSS property. It's actually just called color in CSS. And then we can pass padding, for example, border radius, and we can pass border color. And let's say I make a mistake here, I pass a number. We get a problem because the CSS properties will specify that you need to pass a string here, not a number, right? So it needs to be some string. That's how you can deal with styles efficiently. So this is describing style. All right, so style is an object. And sometimes when you work with objects, you're going to see something else as well. So let me remove all of this. Let's say we just want to have one prop for border radius, right? So border radius means this curved corner, right? And it could be top left, top right, bottom left. So basically you have 4 possible values. So what we want to be able to pass is something like this, a border radius, and maybe that should be an object. And maybe we want to have, let's say, a key being top left, that's where we start, and that should be some number, let's say 5. And then we have top right, should also be some number, and then maybe bottom right, that should maybe be a little bit more, and then we have bottom left. So this is an object that we're passing here that has a string as keys and it has number as values. How would we type something like this? When I save here, by the way, Prettier automatically removes the quotation marks here, but these are still strings for the keys. How do we accept this? So now we're going to have a border radius object here. How do we type that? Well, we have border radius. And now you could say something like, well, we're going to have all of those properties. Right? Top left is going to be a number. Top right is a number. But now we are only specifying the value for top left. We are not specifying specifically what top left itself should be. And so sometimes what you're going to see is something like this. You're going to see record. And then you specify the type of the keys and the values. So for the keys, you're going to have string, and for the values, you're going to have numbers, right? These are going to be strings, and these are going to be numbers. Sometimes what we also want to do is we want to pass a function. For example, we want to do something when you click on the button. We have that function for that specified, not in the button itself, but here. And we just want to pass that to the button. So maybe we have some onClick, and that can just be some, onClick handler. I will just leave this as an empty function for now. So now we're passing a prop here called onClick. So let's go to our button here and now make sure that we accept this. So now we're going to get something called onClick. Here we want to accept onClick, and then we can remove this style. And then of course we want to put that on the button itself. So when there is a click on this button, we want to run that function that we get here. But how do we type a function here? A function as a type for your prop? Well, you just have this syntax. So basically like an arrow function. So here you specify the parameters. Well, this function doesn't have any parameters. And then you have this fat arrow, and then you specify what this function returns. This function right now doesn't return anything. So you use the word void. If a function accepts something, let's say it has one parameter called test, and maybe it returns a number, let's say number 5. And this test is a parameter, so we also want to specify it here when we create the function. Let's say it's going to be a string. Now it has one parameter of type string. So it's going to have a parameter called test. It's going to be of type string, and this will return a number. So instead of void, we would say it returns a number. All right, so let me also remove this. One of the last things I want to show you here for the props is the following. So right now we have this button, and we are just using this without closing tag. But in the real world, instead of hard coding the words click me here, maybe you want to be able to specify it here as you use the button. So you would use the closing tag here, and then here maybe you want to specify it here, click me. Now we're going to get red squiggly lines because it's talking about children. So if you have something inside your opening and closing tags of your custom component, that's called children. It's actually just a prop that you get. So then we have to accept that here. So this is called children, and it's just how React works. That text is just going to be assigned to children. So instead of hard coding click me here, we can just output that here. So now if I save, you can see I added this exclamation mark, but we also need to type this. So how do we type this? So here we can specify children. It's going to be a so-called React node. So in React, we have these elements, JSX elements, but we also have plain text. And we also have, let's say, booleans. And this React node basically allows all of those types to be passed in, whether it's text or I have some other element here that I pass. So if I pass just an empty div, you can see that also works. So if I save here and I save here, this also works. Now, of course, this doesn't make any sense, but this React node is more general, is quite a general type, essentially. Maybe you don't want to allow so much to be passed. Maybe you want to be more specific because maybe you only want to allow JSX elements. A JSX element can be, for example, an icon in this context. So maybe we have some icon. I'll just leave it empty for now, but let's say we have icon now, and that's going to be this. This is so-called JSX element. Just like div is a JSX element, span, these are all JSX elements. Now let's say in this button, we want to pass this icon here, and I have to use curly braces here. So now I'm passing icon here, which is a JSX element. You can see we don't get any errors because ReactNode allows everything to be passed. But maybe we only want to allow elements to be passed, not text, not booleans, only those JSX elements. So we can say, well, this children should be a JSX element. Now you can see this also works. But now if I go back and I try to add text here, if I now try to add text, you can see we get a warning from TypeScript because it says something about doesn't accept text as child elements, because JSX element is more restrictive than a React node. Now in practice, you do want to use React node most of the time. So let me change this back. If I save here, click me, we do typically want to have React node here. All right, sometimes you're also going to have some state. So let's say we are keeping track of the count, but we're keeping track of it in the parent component, let's say. This happens sometimes. So here I have some useState. Let me import this, and I'm using Next.js here. So when you're using these client-side hooks, you want to convert it to a client component. So let me just do that. It's not important here for TypeScript. What we want to do now is when we click on the button, we want to increment the count. So we want to pass this setCount function to button. Right? This is quite common that you pass a setter function like this. So now we need to accept this. So right now we're not accepting that. So here instead of children, let's just hard code it for now. Click me. And now we need to specify what we're going to get with this setCount. Now I get a suggestion here from Copilot, which is actually correct. And this is a very intimidating, weird looking type. And the good news is you don't have to memorize these. We'll talk about hooks more in a second. But here, for example, if I didn't have Copilot, I could just hover this and TypeScript will already tell you what type this is. So you can just copy that type and specify that here. Basically, it's a so-called setter function and it accepts only a number. So here when we call setCount, we have to pass a number here. If you pass in a string, you're going to get a warning from TypeScript, right? And here I have to remove children now because we're not accepting children as a prop. So let me do this self-closing tag again. Okay, so now we got rid of all the red squiggly lines. All right, so last thing I want to show you here is default values, right? You can have a prop with a default value. And if you specify that inline, and if you do that, I can remove all of this. Maybe we just accept the count. And initially this count is going to be the number 0. If I do this now, I don't have to type anything because if I hover this, TypeScript can already infer this count to be a number. It can just look at this and it can see, oh, this is going to be a number type. If you have default values, you don't need to specify the type. Let me also remove this and this as well. All right, let me remove this and let me remove this as well. So far I've been using a type alias as it's called. So here we have button props, and props are an object, and in that object we could have text, we could have some amount, we could have count, it could be a number. This is called a type alias. In TypeScript we also have interface. I could have also written interface button props. So let me comment out the type alias for now. So we have interface and then we also have curly braces here, but you don't have the equal sign here, right? So here with type alias, you are sort of assigning something to this type. Here we don't have that. And then we have text, a string, count as number. And in this case, this is the exact same. We're also describing an object with text as a property and count as a property. And what some people do is if you have an interface, they write the character I in front of the name to indicate that it's an interface. And some people also like to put a T in front of the type alias name. So you will have T button props. It's a bit less common these days. I don't do it myself. So why didn't I use the interface? Well, interface has some issues. For example, with interface, you can only describe an object. So if I have some URL here, for example, and I want to specify that as a URL type, well, I can easily do this with a type alias. I can just say that's going to be a string, right? I have the equal sign and I say that's going to be a string. But how would I do that with interface? If I do interface URL, I cannot do that equal sign, right? So this will not work. So with interface, you're always describing an object. And then in here, of course, I could say URL is going to be a string. But now this is an object. This is just a plain string. So this will work only if I actually make it an object like this, right? So that's the first problem with interface. You can only describe objects. And in the real world, you actually do often want to describe other things as well. For example, we saw a color type. So we had type color, and that was this union type. So we had a type of color with red, blue, green, and this is a union type. You cannot do this with interface. So interface color, I cannot do that equal sign. So immediately I have to describe an object essentially. And this is an object, and this is just a plain union type. So it's pretty much guaranteed that you're going to use a type alias at some point because interface cannot do everything. And since since you're always going to use the type alias at some point, why not just make type alias the standard, the default? So that's what I do. I only use type alias and I never use interface. So in this video, I will focus on the type alias, but other people may use interface. So I will still show you how interface works as well as we go through the topics. So here we're creating a button component, and a button can have many attributes like type is submit or reset. And it has other things as well like autofocus, and it has many other attributes. I can hold control space and you can go through all the attributes that this button can have. So when we use this button component, we may want to use those attributes. So here I want to be able to specify, for example, that the type should be submit, let's say, and that it should have autofocus is, let's say, true. And these are two typical attributes. So now we need to accept that here. So we need to accept these as props. So we need to accept a type prop as well as autofocus prop, and then we can type them individually. Here should be reset or should be submit or reset or button, and autofocus, let's say, should be optional. That should be a boolean. And then of course I do need to specify that the props is going to be of type button props. Right, but now we only have two. We can have hundreds of these attributes. So what you basically want to do is when you have a custom component essentially wrapping like a native element, you basically want to allow all those attributes to be passed as a prop. And we don't want to specify all of them individually one by one. So here's another example of where we can use a helper type. So what we get here when you use React is you also get the component props type. And then in the angled brackets, you can specify which element it should be. Well, here we're using a button element. And when we do this, you can see we can accept type and autofocus. We don't get red squiggly lines here. We can now accept all the attributes that this native button element accepts. This is especially helpful if you're wrapping an element like button, or maybe anchor tag if you're creating a custom link component, right? So then you can just use a, and now you can accept all the attributes that an anchor tag can accept, like href and alt, etc. Right, or image. And then you can accept all the props here that have to do with image, source and alt. All right, now we get red squiggly lines here because this should be on the namespace React. So these helper types are namespaced on React. So you have React.ComponentProps. The namespaces, that's more of an advanced topic. That's not important to understand right now. Now you can use this, but when you look at the description here, it does say, note, prefer component props with ref if ref is forwarded, or component props without ref when you don't accept refs. So sometimes, of course, you also want to pass ref, right? So here you may have useRef, and then you want to pass that ref to a child component like this. If you do this, basically ref now does become an argument, and we need to type that as well. So if you want that, you need to use with ref. So then you also get ref. However, here we don't want to do that. So here we want to use without ref, right? So instead of plain component props, they recommend that you make it explicit whether you're accepting the ref or not. In this case, we don't. So we say component props without ref. Some of these type names are a bit long and confusing, but you'll get used to that as you practice a little bit. So now in our button component, we are destructuring type and autofocus, but we can have all these other attributes as well. So should we specify them all manually one by one here? And the answer is no. So in JavaScript, we also have this rest operator, and you can call that rest or maybe props. I will just call it rest. And this will just wrap everything else that you pass here in an array. So if I pass something else here, like default value and class name, all these potentially hundreds of other attributes that I could pass as a prop here, I'm scooping them all up with this rest operator, and this will essentially just become an array of all of those props now. And then we just want to spread that here on our native button element. And you spread here also with 3 dots, and we can just spread that here. And here we would also specify the type. So type is going to be submit or reset, autofocus is going to be autofocus, etc. And then you would spread all those other props there. All right, let me clean this up a little bit. So now we accept all the attributes that a native button element can have and nothing else. But what if we do have something else that's maybe not an attribute here, but we do want to accept it as a prop? Well, we can intersect. So you have the ampersand and then the additional stuff that you want to add. Maybe we do want to have some kind of variant prop. Maybe this button can be a primary or secondary button, and let's make it optional. So now we accept all the attributes that a native button element can have and a variant prop as well. So now we can also get a variant prop here, which we can then use to maybe style this as a primary or secondary button. So let me actually clean this up a little bit. Let's go back to a clean slate here for a second. Let me remove all of this stuff as well. So we could have a type for button props here. So button props could have, let's say, type and color, red, blue, green. And then maybe we have another component and we need props for that component as well. But that's going to be, let's say, a super button. So a special button essentially, which accepts the same props as a normal button. So we can say button props, but then also something additionally. So we can say we can intersect. So we have and the additional stuff here. Maybe this one accepts a size prop that the standard button does not accept, but the super button does. Right, so it makes sense, right? You just have like a base type and then you can add something to that. And with interface, you would do the same with extending. So let me change this to interface, button props. And here we have super button props. So with interface, we don't have this equal sign. How would we then add something here? Well, you use the extends keyword. So here you have the extends keyword and not this ampersand. So let's remove this. So now we are doing the same as here. And so you're going to see this sometimes. You use extends with interface and you use the ampersand with the type alias. This is called extending. This is called intersecting. So let me remove this and this as well. Let me also remove this. Let's talk about event handlers. So on a button you can click and maybe we want to do something, right? So you have an event handler and could also be on change. And I could specify the handler, the function that you want to run when that event occurs in line here. So maybe I just want to log something. This is a function and usually we type the parameter. We have not typed this parameter e or event ourselves. But if you hover it, you can see it's still typed. It's typed as some very difficult type here, react.mouseEvent, and then with the weird angled brackets. We don't need to memorize this. This is automatically typed by TypeScript because TypeScript has context here. It can see that we're defining this function here in this onClick attribute. It can infer the type for the event from that. However, if you have the exact same function extracted, so here you maybe have a function here called handleClick, and then we have the exact same function here and then we pass that here. That's not the case. So now TypeScript cannot just easily infer the type for event here because we could use this function elsewhere as well. TypeScript doesn't know that we're only going to use it here. It now doesn't have the same context as before. So now we need to type this ourselves. And how would we ever know what the type here is going to be? It was a very difficult one, right? Now what you can do is you can just hover it. So here you can go to the inline version again and you can just hover the event and you can just copy that difficult type. So I'm just going to copy that entire thing and now I can write my handleClick function up here with this type. So I just have colon and then just paste a difficult type. And now this is also properly typed. And of course I can pass handleClick here, right? That's how you deal with event handlers in TypeScript in React. Same with onChange, onSubmit, and these other events. All right, let's talk about hooks and TypeScript. Let me remove all of this. So of course we can also have hooks. Let's say we're keeping track of the count and I like to import it separately. So let me import it like this. All right, so now we have a count variable, which if you hover, you can see has been inferred as a type number. So TypeScript can see what you're passing as the initial value and it can infer what the type is going to be. So here it has correctly inferred the type. So we don't have to do it ourselves. If you want to do it yourself, you can use angled brackets and you can specify the type like this. And then indeed count is still a number. If you would do something like this, if you type it as a string, TypeScript will now complain because now the initial value that you specify is not a string. Here we specified that this count should be a string and now we're passing a number here. So you could do this, you could make it explicit, but it's not necessary. TypeScript can already infer it from that. And that's why you don't really see many developers do that. And same with string. So I can have, let's say text. I could specify that this is going to be of type string, but it's not necessary. If I leave it off and hover text, you can see TypeScript has properly inferred this to be a string. Same with Boolean. Is this the primary button? We're passing in a Boolean here and TypeScript can infer from that this is indeed going to be a Boolean type. I could specify it like this if I want, but it's not necessary. It's not wrong, it's just not necessary. These are all primitive values, but it's different when you have an object type. So let's say we just have a user object and we have set user. Now initially, often with these objects, the initial value is going to be null because maybe you need to fetch the user first. So initially it's going to be null and then after you fetch the user, you're going to set the user and it's going to be an object. But now when I hover user, it's typed always as null. So if I want to do something with that user, for example, I want to get the user.name, TypeScript will complain because user is null. And on null, you don't have .name, right? You don't have anything on null. With an object, you want to specify the type of that object. So this time you actually do want to use the angled brackets. And now we don't have, an out of the box type like string or number or Boolean. We have to create our own type. So we can create a type called user, let's say. And then we can define that up here. We can say type user, and that's just going to be an object with maybe a name, an age, and other things. Now when I hover user, it is of type user, and I can safely access .name here. Now when you do that, you do get another issue, which is we are passing in null. We have just specified to TypeScript that this user is going to be of type user, but now suddenly as an initial value, we pass in null. So TypeScript is telling us, hey, why are you passing null here? It should be of type user. It should be some object with name and age. Well, that's simply because initially it should be null. We're still fetching the user. Initially it's going to be null, and once we have fetched the user, we're going to set the user. So initially it should be null. To work with this, what you often want to do here is you want to say this user is going to be of type user or null. So initially it's going to be null, and eventually it will be of type user. Now this user is going to be of type user or null, and that means it could be null. So when you try to access .name, well, you have to be careful because it's possibly null. You cannot just access .name. So if you do this and user is indeed null, you're going to get an error. Your application may crash. So what you often want to do here is use optional chaining. If user is null and you try to access .name now, it's just going to be undefined, and you're not going to crash or have these errors. So those are types when you use useState. The other hooks we have is useEffect, for example. With useEffect itself, you don't really need to type anything. The other hooks are, for example, useRef. With useRef, you sometimes do want to type something. So here, for example, if I have useRef, maybe we want to get a reference for this native button. We can pass that ref like this, and we can pass the initial value null. And let me import this. Now, of course, initially the value is going to be null. If I hover here, you can see there's ref is some null ref. But of course, we know that eventually it's going to be this button HTML element once it's been properly attached. So here we also want to specify what type it will be eventually. So here we get some helper types again from React. So there is the general element type, but we can be more specific than that. There is also something called HTML element. But we can be even more specific than that. It's going to be an HTML button element. So now this ref will be properly typed. And here we don't have to do or null because useRef works a bit different here with types. The only other hook where you need a lot of typing is when you use the context API. It's too much to handle in this video. I have a separate video on that. Now I want to show you some quick tips and tricks. Let me clean up a little bit here. I will remove this and this. Let's say we have some constant button text options. Click me again, and click me one more time. Now maybe you want to do something with this. Just as a silly example, maybe we just want to map over that array. So we can say button text options map, and for each option we want to do something. Maybe just put it within the button. When I hover option now, you can see that an option is being inferred as just a string. And that's because, well, when we hover this button text options variable, it's been inferred as an array of strings, which makes sense when you look at it, right? What's wrong with this? It's not necessarily wrong. We can just be more specific. So what we can do is we can use as const. This is not JavaScript, this is purely TypeScript. And what this will do is essentially make it more specific than just generally an array of strings. It's now specifically going to be this array only. Right? We're not going to add anything. It's going to be read only, and it's not going to be, any string in the array. It's going to be specifically these strings. That's often what you want to do when you have these constants in a React app. Maybe you have a set of links, for example. Just tag on as const. So you make it more specific than just a general array of strings. It's going to be specifically these strings. The advantage is now when I hover option here, I get the actual values for the option. So I know what the actual values are going to be instead of some general string. And now it's also read only, which means if you try to add something, TypeScript will warn you. All right, let me show you another trick. Let's say we have some user type, and this user maybe has a name and maybe also a session ID, right? That could be a user type. And maybe we also have a guest type. But this guest should be very similar to user. The only difference is we don't know the name of a guest. The guest hasn't registered yet, but we do have a session ID. So what we essentially want is just the user type minus the name. So we have the omit utility, and then you have the angled brackets here. These are sort of arguments in the world of TypeScript. And we can say take the user type and omit the name from there, let's say. When we do this and you hover guest, you can see guest is just a type with only session ID and not name, right? So omit is helpful if you want to take an existing type and you want to remove something from there. All right, one more quick tip. Let's say we are storing something in local storage, and when you want to get it out of local storage again, usually you're going to use the useEffect hook. So useEffect itself, you don't have to type anything here, but sometimes in here you do something where you do need some typing. So if you want to get, let's say, the previous button color, maybe we store this in local storage. So we can say local storage get item button color. Maybe we already have a type for this. So maybe we already have type button color, and that's going to be some union type like this. And this button color, of course, should be just this type. However, TypeScript infers this to be just a string or null. We can sort of assert. We can say as button color. So now when I hover this, you can see this is of type button color, which makes it more in line with the rest of our app that is using this type, right? So you can say as, you basically assert to TypeScript that you know better than TypeScript, and it's going to be this type. There's one concept in TypeScript that a lot of people are scared of, but you don't need to. It's called generics. Let's say we have some function here, convert to array. And the only thing that this function does is it takes in a value and it returns that value in an array. So just square brackets, and we just put in the value like this. And now we want to be able to call this function with, for example, the number 5. But I also want to be able to call that function with, let's say, the string hello. I should be able to call it with different types. And we get red squiggly lines here because we haven't typed this value parameter. It has an any type now. So what's the problem with an any type? Well, the any type means anything goes. So I can do whatever I want now with this value. So I can try doing to uppercase and I don't get any errors. But this is only something you can use on a string. So if I pass in hello, this will be hello.toUppercase, no problem. But if I pass in the number 5, it becomes 5 to uppercase. This will give us an error. It may cause the application to crash. To uppercase is not a method that you can use on numbers. But because we have typed this as any, well, anything goes. So it's not going to give us a warning, but we should get a warning. So we don't really want to have any's in our code base. So we could do something like this. We type it as string, and to make sure that this function does what it says it does, we could say that it returns an array with strings in there, right? So now this will work with strings, and I can do to uppercase. This would all be safe. Now let me just remove this. So this is one example of how you could type it, but of course it only works with strings now. But we also want to be able to pass a number and other types as well, like booleans and other types. So how can we make this a little bit more general? Well, we have generics. So this value, instead of hard coding string, we can say this is going to be some type. And what do we return here? Well, it's the same type, right? So whatever this is, it's going to be an array of that. With generics, we are basically specifying a relationship. The input is going to be of the same type as what you get in the array as the output. Instead of hard coding string or boolean, we make it more general with generics and we specify a relationship here, in this case between a parameter and the return value. We got red squiggly lines here because we need to specify it before this list of parameters that we want to have this t. This is also called a type parameter. So we need to use these angled brackets in front of the parameter list, and then we can specify that this is going to be the t. Usually you want to use t. You can also use k for these instead of t. You can use k, but the convention is to use t. And when you do it like this with an arrow function, you need to pass a comma here. And this looks very ugly, but this is necessary because we're working in TSX. This will essentially be compiled to JSX. And JSX, when you write it like this, it thinks you're creating a React element like div, right, with these angled brackets. Here we need to add a comma, which makes it look ugly, but this is to specify, hey, this function here has a type parameter. We call that t. And then we use it like this. Because of this ugly syntax, I prefer to use a traditional function if you're going to use a type parameter. So let me quickly convert this. I will comment this out. We're going to specify a relationship between the parameter here and the return value. So whatever we pass in, this value can be a string, and then we should get an array of strings. If we pass in a number, t is going to be number, and we should get back an array of numbers. If we pass in a boolean, t is going to be a boolean, and we should get back an array of booleans. Here we need to specify that this function is using a type parameter. You do that in front of the parameter list. So here you can just write t. Here you don't need to use a comma. So I think this looks a bit cleaner, so let me remove this. And now you can see I can call this with any type I want. So what's an example of generics in React components? Well, maybe this button accepts some kind of count value, but then also a history of those count values. So count history, let's say. So now we need to type this, and let's put that in its own type. I like to call it button props. So we have button props, and then we have count value. Now we could hard code this as a number, but maybe it can also be a string, right? Maybe we want to pass like the string 5. But let's hard code this as a number for now. And then what we want to get is a history of those values as well. So that's just going to be an array with those numbers. And now what we can do is we can pass a count value. It's going to be a number, let's say 5. But then we should also pass a history of that. And then we have an array. This could be some numbers here, and this works, right? Everything is a number now, and everything works. However, what if we also want to allow to pass other types, like a string, right? Maybe we also want to allow the string 5. But if we pass the string 5, it should be an array of strings. We have a relationship between these two props. Before we had a relationship between a parameter and the return value. Now we essentially have a relationship between two parameters. What people call generics is actually just a type parameter. So instead of hard coding number here, we want to make it more general. We can say it's not just going to be a number, it could also be a string and maybe other types. But whatever the type may be, it should be the same type as the type in the array for count history. So now we have specified this relationship between these two props. And just like before, you need to specify that this function will use a type parameter. You do that before the list of parameters. So here you can just use t. And now because we have extracted this into a separate type, we also need to pass it from here to here. So we need to add another set of angled brackets here where we also say t. But then this type should accept a type parameter. So then here as well, we need to specify that this type is expecting a type parameter. Right? So now we need to pass two additional sets of angled brackets to make this work because we have extracted this into its own type. If we would just do it inline and just replace it like this, that's not necessary, right? But here it is. The important thing here, and the syntax here is always quite confusing. You just have to remember with these generics is we have just specified a relationship between these two, which means that this count value should be of the same type as what you see in the array for count history. So if I do this now, and now we try to pass in a string here, the string number 5, and you immediately get a warning from TypeScript, which is it's saying I'm using a number here, but it should be a string, right? Because they always need to be the same type now. So if I make these strings, if I now make these strings, you can see the errors disappear. If I make the count value true a boolean, you can see we get a warning again. These all need to be booleans now. Right, so you can see whatever the type is of the count value, that should be the same type as in the array now. We have codified a relationship between these two props by using generics. That's probably the most difficult concept in TypeScript, so it's okay if you don't fully understand that right now. It's also not quite common that you have to do this yourself, by the way, especially not as a React developer. Let me clean this up. So we've seen the most difficult things. There are a couple of other things that you really need to know as well. So let me clean up here. So before we were using some kind of color type. Right, so we had red, blue, green. Now colors, they belong to a theme, and it's possible that other components also need to get access to this type, right? Because other components may also need to be styled in a similar manner as the button. So we need to reuse this type. We need to use it outside this file as well. So we want to put it somewhere else. We don't want to put it in the button component file. So typically we want to create a lib folder, library folder. In here, you may be tempted to do something like index.d.ts to put the type in there, because maybe you've seen that somewhere, and this is not what you want to do. These are treated as special files, as declaration files, and it's mostly helpful for typing third-party libraries that don't come with their own types. So you don't want to use that .d. Instead, you can just create a TypeScript file. So we can call that types.ts, and then we can just put that color type away from here, and we can put it here. And we can just export that, just write export in front of it. And then you can import it here. So I can import the color from that types file. And so now I'm importing a type and I can use that now. So if I have my button props again, I can just use that, right? So I could have other things, of course, children or font size, but now I can also use this color type in other components very easily. I can centralize all the reusable types in my app in a file called types.ts. Now, when you import a type, what you can also specify is that it's going to be a type, because without it, it kind of looks like a normal JavaScript variable that you're importing here. You can write type in front of it to make it extra clear that this is a TypeScript type. There are some other benefits of doing that, but those are very small. I think the main benefit of doing this is that you just make it very clear and explicit that this is a TypeScript type and that you shouldn't do anything with it like new color, like treat it like a normal JavaScript variable. You should only use it as a type. So you will see that sometimes. What you also need to know, let me remove this, is the unknown type. So if you have useEffect again, you're fetching data, let's say, you want to do that in useEffect. Let's say we're fetching data, right? Maybe you're fetching some to-do. We get a response, we're going to parse that as JSON. And then finally here, we get the actual data. So the data that you get back from an API, when I hover here, by default, TypeScript types this as any. And as we've seen before, we don't want to have any's in our code base, at least not when we can do something about it. The problem is here that we don't really know what we're getting back here. We may have some idea of what we're getting back, but we don't know for sure. You know, there could also be an error error on the server here. We may be using the wrong URL. Whatever the case, you can never really trust what you're getting from some external API. And so we don't really want to type this as any because it can cause a lot of bugs. The more appropriate type here is actually called unknown. Unknown means we don't know anything about it. So you cannot just start using it. And so here, before we actually start doing things like data, name, .to uppercase. And so before we can actually start using these methods, we need to verify that what we get back here is actually the shape that we expect. So when I hover here, data is going to, if we're going to get an issue here, TypeScript will tell us it's a type unknown. So you cannot just use this. So this is actually where schemas come into place. So maybe you've heard of Zod and other schema validators. So what you want to do here is you want to run it through Zod, where you basically do something like this. You have some schema and you're going to parse. You can use the parse method on there. You pass in the data and it will tell you whether that data is indeed that particular shape. Once you've done that, you can just use it as before, do something with the data. So if you can, try replacing those any's with the unknown type and try to use a schema validator like Zod to make sure it's of the particular shape that you expect it to be. It's outside the scope of this video. It would be a bit too much, but check out my other videos. Now, if you don't want to manually do this typing from any to unknown yourself, you may want to use this ts reset package from Matt Pocock. With this package, it will make sure that whenever you fetch data, the data will automatically be of that unknown type. And it has some other benefits as well. It's also outside the scope of this video to install all of that. So make sure you check out my other videos or my course on React and Next.js, in which we will also talk about TypeScript and also all these little details. Some other things that you really need to know are the following. Let me clean this. Let me close this. So previously we were actually using a type from React. We did something like children, and then React.ReactNode. So this is the React namespace, but this is a type that we get from React. We also used one for style. So we had something like React.CSSProperties. These are helpful because then we don't have to create this type ourselves. We can just use something from React. So where are these types coming from? Well, if you go into the node modules, you will see something called add types. And this is where a lot of your third-party library types will come from. So here we also have React here, React DOM, and also Node for Node.js. So that add types is a repository for high quality TypeScript type definitions. It's also called DefinitelyTyped, and it's basically just a big collection of types for third-party libraries. Because when Microsoft came out with TypeScript, a lot of those libraries weren't using TypeScript yet. So that was a bit of a problem to start using TypeScript. So with this project, a lot of the most popular third-party libraries like React and other ones as well get some types from here, right? So that's where this is coming from. Now, when you're using a framework like Next.js, usually you're going to have some other TypeScript files here as well for configuration. So typically the file that you're always going to have is a tsconfig file. And here you basically decide the settings for TypeScript. So TypeScript is going to compile your TSX file into a JSX file. And you can determine how exactly that should go with this JSX option. That's not really interesting. In Next.js by default, it's set to preserve, but you don't really need to use that. The only other option here that you may want to use is this strict option. I'm using a Next.js project here, and in Next.js, it's set to true by default. So what that means is that your TypeScript is going to be strict. So as a quick example, if you remember, we looked at when you have a state that's going to be null initially. So for example, some user state, and this user can just be an object with name and email. But initially it's going to be null because maybe we're fetching the user. Now, when it's set to strict, if you try to use that user variable, for example, to get the name, we're going to get red squiggly line here because it could possibly be null. However, if you set this to false, if I set this to false, you can see the red squiggly line disappears. So it's less strict. However, I think it's better that you actually try to be strict with yourself and really make sure that when you try to access some property or method, that it's not null. So just add this, or you can just do it like this. Typically people use the optional chaining method, and this strict setting doesn't only affect this, it also affects some other things. In general though, you do want to be strict, but typically your framework will already have set all of these settings for you. So you don't really need to change anything here. Now in Next.js specifically, we also have this next next-env.d.ts file, and this references the types for Next.js. So if we're using some Next.js specific feature, we also want to get correct typing, and this makes sure of that. So as a quick example, if you're fetching data, you can do that in a server component these days. We can fetch data to some URL, and what you can do in Next.js has extended this, so you can actually write next here, and this is actually an object. And then here, what can I pass? I can do control spacebar, and I get some intelligence here. It's telling me I can pass revalidate and tags. If I try to pass something here that's a string, I get a warning here because it should be a number. This is a Next.js specific feature. They have basically altered the fetch API a little bit to do some additional things. And as you saw, we get IntelliSense and we get that typing because we are including this file as well, which is referencing where those types for Next.js are. So that was a lot to take in. It's completely normal if you're a little bit confused right now. Now I have a complete React and Next.js course in which we also talk a lot about TypeScript. You will see a lot of practical applications. So I highly recommend you check out the links in the description. In any case, thanks for watching, and I hope to see you in the next one. Bye.